Okay, welcome to our new lecture, which is the pandas merging, joining, and concatenation. So, Panda also provides three simple methods like merging, joining, and concatenating. These methods help us to combine data in various ways, whether it is matching columns using indexes or stacking data on top of each other. So this is basically useful when we have scattered data, and first what we will do is that we will import these data into the data frame class as objects, and then we will merge them or combine them in a variety of ways to keep them in a single data frame. The very first one is the concatenation of the data frames. So concatenating data frames mean combining them either by stacking them on top of each other vertically or placing them side by side. In order to concatenate data frame, we use different methods which are as follows. The very first one is the concat method. So concat method allow us to combine multiple data frame into specifying access rows or columns. So we will be using only the columns. So for this purpose, we will import pandas packages pd, pandas packages pg, and then we will be creating two data frames. The first one, which is currently as a dummy data, and this is the dictionary. So there is a name, key, age, key, address, and qualification, and the second one also has the name, age, address, and qualification. So we will import these two dictionaries as pandas data frame, and the first one will be stored in the df object, the second one will be stored in the df1 object. And after so let's first hide all the current outputs. Okay, so first we will import the dummy data. So now this is the first data frame, and its object name is the df, and this is the second data frame and its object name is the df1. So now we will be using the concat function in order to concat two data frames. So this is using the concatenation. So as you can see that the default behavior is the union of the two data frames. So this is the data from the data frame 1 object, and this is the data from the data frame 2 object. So now we can also see that the index numbers are the same as the original data frames in the data frame and the data frame 1. So now just in order to reset the indexes from 0 up to n minus 1, what we can do is that we can use the reset underscore index method here, and by providing drop is equal to 2 is equal to true argument. This will help us to reset the indexes from 0 up to n minus 1. Okay, so now we can modify the concatenation method by setting logic on the axis. Specifically, we can choose whether to take the union, that is union of the two data frame, which is the default behavior which we have just saw, and we can also change the behavior to the intersection of the two data frames, that is uh, the data which is common among the two data frames will be only selected and the rest will be discarded. So again, we have the exact same data. This is the data 1 and this is the data 2. We have now imported the first data as the df and the second one is the df1. So now again, this is the output of the exact same two data. So we have the name, age, address, qualification, and mobile number in the first data frame, and we have a slightly changed data frame, that is the name, age, address, qualification, but we also have now a salary label. So now you can see that in the first data frame we have the index number 2 and 3 are similar to the index number 2 and 3 of the second data frame. So only two rows between the two data frames are similar. So now using the concatenation, access1 means that we want to concatenate based on the data under the columns, not exactly based on the rows number. So now by using join is equal to inner, it will only select the data that is the common between the two and discard the rest of the data. So now we can see that we have the two data between the two data frames that have been not only concatenated based on the columns. So the column names are also concatenated, but the data which was completely different between the two have been discarded. Now, in order to take the union based on the you can say columns, what we can do is that join is equal to our outer. Okay, so join is equal to outer. This is the concatenation method, and we have provided the list of the data frames. So currently we have only two data frames. That is, this is the first data frame as the DF and the second as the DF1. Access is equal to 1 means that we want to concatenate these two data frames based on the column labels, and we want to take the union. Okay, the term outer means union. So now taking the union of the two data sets, which means that the union of these two database will be performed based on the columns. So these two columns will be concatenated with each other. So as you can see that when we do not specify access is equal to 1, then the default behavior is the access is equal to 0, and in that case the concatenation occurs based on the rows. So you can see all these two rows are concatenated with each other, but when we set access is equal to 1, then the concatenations occur based on the columns. So the columns of the two data are concatenated with each other regardless of the fact that if the column name is same, it doesn't really matter. So these are the column labels from the second data frame, and these are the column labels from the first data frame. But in that case, even those data that are not common with each other are also selected when we set join is equal to outer. Okay, so as you can see that the indexes number here are not in the ascending order. That is, index number 4 is missing, here's 5 is missing here. Just in case if you want to reset the indexes from 0 up to n-1, you don't have to do the extra step of the reset underscore index method. Instead, you can use the ignore underscore index is equal to true. So now we have these two data frames with their particular corresponding data. First we will display. So this is the first data in which you can see that the indexes are 0, 1, 2, 3, and the second one is 2, 3, 6, and 7. Since we have used join is equal to outer, and we have not specified access is equal to 1, which means that concatenation will be occurred based on the rows, not based on the column labels. So the columns having the so the columns will having a same name will be appeared only once. So let's see the output. So here we can see that name column was also available in the first data frame and also on the second data frame, which means that access is equal to access has been set is equal to 0 by default. So the access has been set is equal to 0 by default, so we do not have to specify it. So access is equal to 0. This is the default behavior. In the previous two, we can see that access has been set is equal to 1, that the concatenation of the columns will be occurred instead of appearing only once. So that is why when we do not want to use the access equal to 1, then we do not even have to specify it. Instead, access equal to 0 is the default behavior. So here you can see that concatenation has been occurred based on the rows, but since we have used another argument in ignore index is equal to true, which means that in previous indexes will be ignored and the new indexes will be assigned when we use the concatenation method. So here you can see that the new indexes has been set, that is from 0 up to n minus 1. Concatenating data frame with group keys, which means that now we have again the two data. So first we have set the indexes to different indexes, which means that the indexes assigned to the data, first data frame will be 0, 1, 2, and 3, the second will be 4, 5, and 6. We can see it in the output as well. This is the first data frame in which we have the indexes starting from 0, 1, 2, 3, 0, 1, 2, 3, 4, and the second one is 4, 5, 6, 7. So now if you want to see that, first we want to use the concatenation method, and then in the frames we have the list of the data frames. This is the first data frame and this is the second data frame. So this is basically the list of the data frames, and then we have signed the key x to the first data frame and key y to the second data frame, and ignore index is equal to false will reset the index in the resultant data frame. So in this particular output, now we can see that which indexes have been added to this concatenated data frame from the x. So this label x states that these data is basically from has been concatenated in this newly created data frame from the data frame first data frame, and uh, the rows under the y label have been taken from the second data frame. Concatenate mixed data frame and series. So you can also concatenate a data frame with a series. By series we mean only a data in a single direction. So this is the first data, and we have converted this data into the data frame by using the indexes. So here you can see the indexes have been used as 0, 1, 2, and 3. So this is basically the default indexes. So even if you do not use it, then there is no need for it, because the default behavior is exactly the same. So anyhow, we have now created a series. So uh, you have to use the series method, a series class of the pandas module. So here there are some values, and what we want to do is that we want to assign these values under the salary column. So this will basically create an object of the series class. First we want to display the data frame and then the corresponding series. So this is the series output and this is the data frame output. Now we want to concatenate this data frame with the series. So first we have provided the list of objects of the pandas module. The first one object belongs to the data frame class. The second object belongs to the series class. So now we have set access is equal to 1, which means that we want to concatenate this series with the data frame in terms of the columns, not the rows. So this series will be added as a new column instead of the new row. And join is equal to outer means that we want to perform the uh, union of the series and the data frame. Index is equal to false means which means that we want to reset the indexes from 0 up to and -1. So this is the resultant data frame, which is the concatenation of the data frame and the series. So the series has been added as a new column with a label salary, and the corresponding list of data has been assigned to each row respectively. So now the second technique is merging of data frames. So merging of data frame in Pandas is related to performing SQL joins. We do not want to go in the details of the SQL joins. However, the merge function provides flexibility for different types of joins. So we have basically four different type of joins. That's the inner join, the left join, the right join, and the outer join. So the default behavior is the inner join, that is there will be a how argument, and if we do not assign any value to the how argument explicitly, then an inner string value will be assigned to it by default. So this is the behavior of the inner join, which means only a common data between the two data frames will be selected. And this is the behavior of the left outer join, all the data from the left data set and only the common data from the right data set will be selected. This is the default behavior, or this is the behavior from the right join, which means the complete right data from the right data frame and only the common data from the left data frame will be selected. So if we set the outer join, which means that all the data from both of the data frames, that is the left, right, and the common data between them, everything will be selected. So now first we will use the merge method with on argument with a single key. So this is the demo data, this is the data 1 and this is data 2. Now we are importing data 1 as the df and the second data as the df1. So let's see the output of the df and the df1. So this is df. In df we have the key column label, name and age, and in the df1 data we have the key address and qualification label. So you can see that the key column is the common between the two data frames. So now what we can do is that we can merge the two data frames based on the key column, as the key column exists between the two data frames. So that is why we'll be able to merge the data frame. So this is the merge data frame and this is the first data frame and this is second data frame. Now you can see that you do not need to specify the data frames in the form of the list. You can explicitly write the first data frame, then there will be a comma and there will be a second data frame as an argument, as a second argument, and then there will be the third argument, which is the on argument, and we have set a single key here within the single quotations. Now what will happen is that these two data frames will be merged based on the keys from both the data frames. Since the keys are common between the two data frames, that is the k0, k1, k2 and k3, so exactly the same keys are also present in the second one. So that is why both the data frames will be joined and we will see all of the data between the two data frames. So now let's suppose if we change a key. So as we just specified that the default behavior will be the inner join, that is only the selected data, this one. So what if we change the key deliberately? So now we know that k0, k1, k2 and k3 are present in both. So what if we change a single key, that is the key 4? We have set key k4 in the second data frame. So now the resultant data frames are a bit different from each other. The first one contains the keys as K1, K0, K1, K2, and 3. The second one is the K0, K1, K2, and K4. So it means that K3 is different from K4, and now we have only specified the on key, which depicts actually that how is equal to inner. If we do not specify, then this will be the default behavior, which means that only the data which is the uh, common between the two data frames will be selected only. So first we will see the output by explicitly specifying it. So now you can see that K0, K1, and K2 are only selected because these two values under the key columns were present in both the data frames. So now you can see K0, K1, K2, and K3. And since K3 and K4 are different from each other, so that is why neither K3 is selected from first data frame and K4 is selected from second data frame. So this is basically the default behavior which we are going to learn in a while. Since it is not mentioned here, that is why it is showing its default behavior. So now if we set the keys back to K3, then again, since all of the keys are the exact match in the two data frames, that is why selecting data based on the key column, we will see all of the data from both of the uh, data frames. Okay, so now merge using the on argument with the list of keys. Previously we selected data based on the single key. Now there are multiple keys, so this is the first key and this is the second key column. Similarly, we have the first key column and this is the second key column. Now incorporating these two data is the data frame and the df1, df and df1. So this is the df1 data frame information. So this is the first key and this is the second key of the df, that is first data frame. The second data frame contains also the exact same label, that is the key and key1. So now if we observe it closely, we can see that the key column of the first data frame and the second data frame are exactly same, but the second key column, that is the key1 of the first data frame, is K0, K1, K0, and K1, whereas the second data frame, the key1 column has slightly different values, that is the K0, 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 K0. So the similar columns based on the key and key1 columns are K0, K0, which is present here, and K0, K0 is also present here. And similarly, we have the K2 K0 here, and we have the K2 K0 here. So what is actually happening here is that we have now provided a list of key instead of a single key. So what happens is there first it will filter or select the data that is common between the two data frames. So since we already know that the data under the key columns are exactly the same match as the second data frame, so there is no issue in it. So first selection will be based on the key column, and then if any data is selected based on the key column, then there will be second phase of selection, which means that even column data should also match so that the resultant data is added to the new data frame after merging. So after merging, we can see that only those data is selected in which the key and key1, both the labels have exactly same data in both of the data frames. So again, K0 so K0 is present in the first data frame, and then K0 is also present in the second data frame. That is why this particular complete row has been selected, and their labels have also been merged, which means that the name and age label is selected from the first data frame, and then the address and qualification label is selected from the second data frame. It has been added as a single row in the resultant data frame after the merging. Same is the case for the K2 and K0. that the K2 and K0 is present in the first data frame, and the K2 K0 is also present in the second data frame under the key and key1 labels. So that is why their corresponding data will also be fetched. That is the under the name Liam, and under the age 22 will be selected. So there is Liam and age 22, and then under the address uh, we have the Toronto and BCom. So under the address we have the Toronto, and under the qualification label we have the BCom. So again, we can see that the default behavior is the common data between the two data frames. So now there is quite a bit detail about the how argument, since we already know that the default behavior of the how argument is the inner, that is the intersection of the two. And if we set the inner, the how is equal to left, which means all keys from the left and the common keys from the right data frame will be selected. And if we select it to the right, which means that all keys from the right data frame will be selected and only the common keys from the left will be selected. And if we set argument as outer, it means that all the keys from left and right and data frames will be selected. So now again, there is the exact same data which we used for the previous uh, output have been used here. So first we have created our data frame from scratch to avoid any inconsistencies. So again, you can see that the data under the first key is exactly the same as the second data frame, and the data under the Q1 is slightly different, which means that K0 K1 K0 K1 is present in the first data frame, but in the second data frame only K0 is present in all the rows of the second data frame. So now we are again performing the merging based on the multiple keys, and we saw the exact same output. So now this time what we have done is that we have set how is equal to left, which means that all the data from the left data frame will be selected, which means the complete data of the left data frame, and only the common data from the right data frame will be selected. So now let's see the output. So K0 K1 K0 K1, these are basically all the keys of the data frame 1, which you can see here. So let's see the output of the data frames as well. So you can see that name and age column of the first data frame and all the data under these columns are selected. So you can see that the name and age, all the data have been selected, but from the right data frame what has been selected, that whose keys are the exact match with the first data frame, which means that K0 is here, and then the K2 and K0 is also here. So it means that John 27, sorry, which means that New York and BTEX are going to appear in the resultant data frame after merging and Berlin and BCom. You can see that the New York and BTEC, sorry, New York and BTEC, Berlin and BCom. New York and BTEC, Berlin and BCom. This is not Berlin. This is basically K2 and K0. The name. Since we are using different data each time, so let's see the output again. So it means that K0 from the first data frame, and second the New York and BTEC should appear in the resultant data frame, and then the K2 and K0, which means that K2 and K0, Berlin and BCom. So let's do it once again. So here you can see the New York and BTEC from the second data frame because its keys were the exact match to the first data frame, and then the Berlin beacons are also selected from the second data frame because its corresponding keys are also the exact match. So this is the result of the argument how when we assign left string to the how argument. So since the k1 is not the exact match to the first data frame, so we cannot see the k1 in the second data frame. So since we do not have any k1 keys here, so that is why no data is available. So that is why not allocated is has been appeared here. And similarly k3 and k1 is also not present in the second data frame, so that is why k3 and k1 keys do not have any data here as well. So now if we set the keys to the right, what it actually means is that all the data from the right will be selected. So this is the data frame 1. So this is basically the data frame 1. So this complete data will be appearing in the right data frame, and only the common data from the left will be selected when we set the keys is equal to how. So let's see the output. So now you can see that all the data from the right has been selected when we set how is equal to right, and only those data that has the exact match with the right based on the keys are selected. The John and age 27 has been selected from the left because it was it has the common keys with the right data frame, and then again k2 and k0 is the exact match with the keys of the right data frame, so that is why data from the left data frame has also been fetched here. So now when we set how is equal to outer, then regardless of the fact that whether the data under the key label and key1 label are matched or not, all the data from all of the two data frames are fetched. So you can see all of the data, that is BTech, New York, London, BA, Berlin, BCom, and Sydney, are fetched from the second data frame. Since in the second data frame we do not have any data next to the k1 key, so that is why not allocated, not allocated, or no value has been seen here. Since in the second data frame we also do not have the k3 k1 key, so we do not have any data here. However, you can see that number of data has been increased from the 4 rows up to 6 rows. This is because of the merging based on the outer join. Same is the case here, since we do not have any k1 k0 key in the first data frame, so that is why not allocated has been seen here. And similarly we do not have any k3 k0 combination of keys in the first data frame, that is why we can see that there is no data available under the name and age for the k3 and k0 combination of keys. Now when we set to the inner, we also know that the inner means is the data which is the common between the first data frame and second data frame. So that is why we will be seeing a data that has the exact match in the two, and there will be no allocated values. So now the third way to combine two data frame is the join method. So in both data frames we have the same index, we can use the join functions to combine their columns. This method is useful when we want to merge data frame based on their row indexes rather than columns. So this is purely based on the row indexes. We do not consider columns here. We only consider matching based on the row index labels. Now for the sake of testing, we'll be creating data frame based on the dictionaries. This is the first dictionary and this second dictionary. The first dictionary contains the name and age only. The second dictionary contains the address and qualifications labels. So now setting the manual indexes k0, k1, k2, and 3 to the first dictionary. That will become the row indexes for the first data frame. And the second data frame, we are going to create the k0, k2, k3, and k4 as the row index level. So the resultant data frames are this is the first data frame in which we have the name and age column, but the indexes start from k0 up to k3. In the second data frame, we have the address and qualification column labels instead, and the indexes are starting from the k0, but we do not have k1 row label here, and we also do not have the we do not have the k1 label here in the second data frame. In the first data frame, we do not have the k4 label. So there is a slightly difference between the two data frames based on the row labels. Okay, so we have to keep that in mind. So if we do not specify that when joining the two data frames, whether the inner join behavior should occur, left join behavior should occur, or right outer join. Okay, so the default behavior will be the left inner join, which means that if we do not specify anything here, as an example, we are specifying that the left data frame is df, and we are calling the function join using the first data frame, and then we are specifying the data frame 1 as an argument, but we have not specified anything here that either to select data from both of the data frame based on intersection or union of data frames. So as a result, the default behavior will be that all the data frame from the left data frame will be selected, and only the common data from the right data frame will be selected based on the row indexes. So now we know the row indexes. The row indexes are the k0, k1, k2, and 3. So this is the first data frame, and because the default behavior will be the left join, which means that all the data from the left data frame will be included in the resultant data frame, but from the right data frame only the data whose indexes are similar to the first data frame. So we know that k2, k0, k2, and k3 are similar to the row indexes of the first data frame. So it means that k0, k2, and k3 from the second data frame will be selected. We will not see any k4 index in the resultant data frame. So this is the result. So now we can see that k0, k1, k2, and k3 indexes, because all of the indexes from the left data frame are selected, but since we do not have any k1 index in the second data frame, so it means that London PhD will not appear in the second data frame. Instead, not allocated values will be assigned here. So now when we set how is equal to outer, it means that union of both will occur. It means that all of the data from the left data frame and the right data frame will be selected regardless of the fact whether their indexes are matched or not. We will see all of the indexes from k0 up to k4 in the resultant dataset. So let's execute this code. So we can see all of the indexes, that is the k1, k0, k1, k2, k3, k4. But we know that for the k1 we do not since we do not have this particular row index in the second data frame, so that is why there is no address and qualification in the resultant data frame after setting how argument is equal to outer. And since we do not have k4 row index in the first data frame. So that is why I do not have name and age values for the K4 index. So that is why we can also see the not allocated values here. So now joining data frame using the on argument. So again, we have the uh, demo data here in the form of the so we have the demo data frame in the form of the dictionary. So this is the first dictionary and the second dictionary. Now we have directly created a data frame for the first dictionary, and since we have not provided any information regarding the indexes, so the default indexes that is from 0 up to n-1 will be set as labels. But in case of the second dictionary, we have specified the row labels as k0, k2, k3 and k4. So the resultant data frames will have a completely different type of row labels. The first data frame contains the row labels as integer values, that is 0, 1, 2 and 3, 4. But the second data frame has k0, k2, k3 and k4 as the row indexes. So now what will happen is that when we join the left data frame with the right data frame based on the on attribute as key, which means that since we also have a key column in the first data frame, so what will happen is actually that the key values under the key columns will be matched with the default or row indexes of the seconds. Again, the key column values will be matched with the row indexes of the second data frame. So we know that the keynote is the in the first row of the first row index of the first row is a match. Similarly, we have K2 also available here. We have K3 also available here, but we do not have K1 in the second data frame and we do not have K4 in the first data frame. So it means that since we did not provide or we are not providing information regarding the how, it means that uh, left how is equal to left will be selected, which means all the data from the first data frame will be selected, but from the second data frame only those data will be selected which is the exact match on the key columns of the first data frame and with the row indexes of the second data frame. So now we can see the result here. The result shows that all of the keys have been selected based on the key labels of the left data frame, but from the right data frame only those uh, data are selected whose row labels are exact match with the uh, key column values of the first indexes. Okay, now joining data frame with different index levels, multi-key indexes. So now we have again, this is slightly difficult to understand, but if you take a good look of it, that we can understand it. So this is the first data frame. It's exactly the same which we have created. This is the second data. Now, while creating the first data frame, what we are doing is that we are creating index is equal to pandas dot index, which is the k0, k1, k2, and we are naming name is equal to key. So there are only since we have only three data in the first dictionary. So for creating the a new column label that is the key here, we have only the three values under this is. So let's see the output also. So this is the first data frame which we are creating. While creating this particular data frame, we are setting the, you can say, sort of the index naming as the key. Okay, so this is basically a column and we are setting this column as an index in the resultant data frame. So we are taking a shortcut here. So first, instead of creating a data frame and then setting the key column as the index, so we are setting so we are telling over data frame class that I not also want to create a new column here, but I also want to create this column as the row indexes in the resultant data frame. So what we can see is that a key column was first added and then this key column was also set as index in the resultant data frame. Similarly, what we are doing is there we have only two columns in the second dictionary, but at the time of creating the you can say data frame, what we are telling here is that I want to set a multi-index from tuple. So this is basically a method to create an index separately. So this is a multi-level index. So we'll be creating two levels of index. The first will be key, and under the key there will be values k, k0, k1, k2, and k3, and under the second index level y we will be having the labels y0, y1, y2, y3. So while creating a second data frame, first we are providing the second data, that is the second dictionary here, this one, and we also specified the index is equal to index which we already created here. So a multi-level index will be created. As a result, we can see in the resultant data frame we have the data from the dictionary which we created earlier, and we also have the multi-level keys. So these are basically the multi-level indexes. This is the first index of this particular data frame and this is the second index here as well. So now what we are doing is that we are joining the first data frame with the second data frame. So this is the left data frame and this is the right data frame, and we are creating how is equal to in. So what we can see is that it's basically uh, performing a check here, is that the keys from the first data frame should match or inner means only those data will be selected which is common based on the key combination of the first data frame and the second. So k1, so k0, k1 and k2 is present here. So in the second data frame, k0, k1, k2 is present in the first level of the key and the second level of key. It has the k0, k1, k2 and k3, k0, k1, k2 and k3. So k0, k1. Okay, currently it is only matching the key indexes of the first data frame with the key indexes of the second indexes. So k0, k1, k2, k0, k1 and k2 are selected from both of the data frames. So this is it from the pandas for combining two data frames, and we have learned basically three techniques, which is the concatenation, merging and joining. So this is from it. If you have any questions you can ask.